Good morning, ladies and gentlemen. Welcome to day 2 of our Kansasfest talks. And we're kicking it off now with Mr. Vince Weaver, who is going to discuss Apple II programming adventures. Take it away, Vince.
So you can see I'm presenting here from inside of an emulator, Top Art Road, and it's clipping the edge off here, which is sort of unfortunate. I should test that beforehand. But part of the hassle here is I'm running Linux on this Mac, and then I'm running AppleWin inside of the Wine emulator, and it's a little complicated. So, come on. So yeah. So about me, I am a professor at the University of Maine in Orono, Maine, and if you squint really hard, that's Mount Katahdin in Maine, tallest mountain in Maine. That's where the Appalachian Trail ends. That's where I was about a week ago. It's a brand new national monument, Woods and Waters National Monument, that they built. There's not a single person in it, 10,000 deer flies, so it's probably why there's no people in it. But at the University of Maine, I do various things. I do mostly things like high-performance computing and hardware performance counters for measuring, how performance supercomputers, things like that. I also do embedded systems work, and I do a lot of work with Raspberry Pis and things like that. And you might ask, is there a Apple II connection for University of Maine, out in the middle of nowhere? It turns out that Chuck Peddle went there. He's one of the designers of the 6502 processor. He actually went there. And no one there remembers it all, actually. I actually found out about it because I saw Wikipedia. And they were giving out awards for a famous alumni. I'm like, why not Chuck Peddle? Everyone's like, who? I'm like, but eventually they looked him up, and now it's probably actually bags. They're probably bugging him to donate money or something now. But they finally realized they're a famous alumni now. I think we should build like a statue with 6502 chip or something on campus. It'd be cool, but I like that. But so a slight connection there. So about me, I've been using Apple II since I was fairly young. So again, if you squint a bit, it's me sitting, well, you actually can't see me because I'm clipped off there, but there's the Apple II, and that's me. Growing up in my neighborhood, we weren't like a very fancy neighborhood necessarily, but everyone in my neighborhood had Apple IIs for some reason. I didn't actually meet someone who actually ran a Commodore 64 until I was in high school. So, and my dad taught high school computers at the local high school, and when he first started, it was doing punch cards and taking them in once a week to the IBM mainframe, getting your printout and then having a week to debug before you do it again. But by the time I came around, they actually had a small lab of Apple IIs. I actually got to use the punch card machine a few times. But and sometimes he would bring one home in the summer to do work on it and such, and he let me use it. And so I get books out of the library, and I type things in out of 321 Contact magazine and all that. And so because of that, I spent a lot of time putting in basic programs and all that, and I actually saved them all, and I imaged them at one point. So I have all these disks full of these old basic programs. You can see this nice little, my dad made that program for me. They had the little thing. And so I just have, 5 to 10 disk images, and just full of all these tiny basic programs with stupid names and full of just random things. And, I never comment my code, so you know where they're all from. So it's sort of fun. So if you ever wish you had all your old basic programs from your kid, I'd say, it's actually not as exciting as it sounds. So yeah, my family eventually did get a machine, a 2E. My grandfather was an early adopter, and he moved to an IBM PC fairly early on, and so we eventually, I think, got his Apple IIe. And so we had that for a while, and we started calling BBSs. We used to call BBSs in a 1200 baud modem. You'll sometimes see, I go to my BBS handles Dieter, so you'll see that used a lot. And actually, I'm not sure where it's from. We logged into an Apple II BBS. My dad, that's just what he put in for my handle. I'm actually not even 100% sure where it came from. But the local high school he taught at, they actually set up an Apple II BBS. They had it there, and they had a cider hard drive, and you can call them into it and all that. And this high school ran that BBS for years. Interesting enough, for a while it was called Captain's Quarters BBS, and I know the newish Apple BBS is called that too. I'm sure it's a coincidence. It's just sort of a weird coincidence. But anyway, I was always trying to write games, and they're in BASIC, so they're never very good games. So I have the demo of sort of what the best game I ever wrote at the time was. So it's called Alien Control here. And I always forget the keys, instructions. So yeah, this is when I was, elementary school. This is where the limit of my game writing abilities was. So, but luckily for this talk, I did get better eventually. So So I was just starting to, this was about, I guess, middle school at the time, and I was starting to learn 6.5 assembly. But then my family got a 386 around 1991 or so, and I moved to Turbo Pascal and DOS, and so I just sort of stopped using the Apple II for a while. And in 1996, I went to college, and I moved to Linux, and I sort of moved to Linux permanently. And so in college, my dad's high school, remember all the Apple IIs, they threw them all out in the late 90s, and so I managed to snag Apple II Platinum when they were throwing them out. So that's the machine I still use for my development. And when I was there, I found Usenet, and I was interested in looking at Apple II stuff, but for a reason at the time I was in, it's just the beginning of the endless September there, and it was just sort of a mess. There was flame wars, and it wasn't a very friendly place, so I just sort of stayed away from Apple II development. But I never forgot that I'd always wanted to make a 6.2 assembly game. So you might have heard one game I made was this game called Bombem. So this was a game that around 2002 or so, I have a game, it was called Bombem, I wrote in DOS, in Turbo Pascal, and it was just sort of a little fighter game. And I did it as part of a 1K programming challenge they had online. And I couldn't actually fit the full version of the game in 1K, but I had a sample version of it. And I remember the memory I have of this is I know I submitted it, and someone, an Atari 2600 developer commented on it, and he's like, wow, it's got blocky graphics. And I'm like, wow, for an Atari 2600 programmer, that's sort of mean. And so it's open here. I'm going to show that briefly. And so around this time also, in order to get stuff onto the disk image, I was doing development under Linux. So I used the CA65 assembler, and I wrote actually tools, the DOS 33FS tools that let you mount disk image under Linux. And I actually wrote a file system driver for a while where you could actually mount your DOS 33 file system under Linux and use it like an actual file system. But I haven't maintained that for a while, so it's not working. But it also has some tools for loading up disk images and stuff. I'm going to use that still. And so it's just sort of a silly game. And actually doesn't look like much, but it's the most complete port of this game there is. The actual DOS version is never finished, the Linux version is never finished, but this one you can actually play. And so it's just a little game, and these things come down here and all that. So that was for a while I'd worked on. And so later, this is around 2012, and this is where the software I'm using right now came from. So a coworker of mine, I was at doing a postdoc at University of Tennessee in Knoxville, and a coworker, trying to be funny, gave an entire we have weekly lunch meetings. He gave an entire presentation of his iPad. This is the place where they do the supercomputing stuff, so LinPack, for the top 500 computers, and he actually is the one who ported LinPack to the iPad to show that, the iPad is just as fast as a Cray, whatever. So he presented the iPad. So my talk was a few weeks later, and so I thought I'd one-up him by bringing my Apple II in and giving the entire presentation on the Apple II. And, that sort of got out of hand, and I ended up writing an entire program that would take your slides that you made in the text, and it would actually make into an Applesoft BASIC program, and then set up things and do the little thing in the bottom here, and have the load the graphics and all that. So anyway, so that's the software I'm using here. I figured, if there's any place to use software like that, this is the place. So that's what I'm using here. And actually, I started sending my project into the Hackaday website, and this made it. And so this project went mildly, not really viral, but a lot of people around the world got posted in some magazines and all that. And so a little bit later, I moved on. After later, I moved to Maine and all that. And I started messing around with Applesoft again because it's the first programming language I use, and I like using Applesoft. And so I started trying to take modern things and sort of rewriting them in Applesoft just to see how well they'd run. And one thing I did is I wrote a web server entirely in Applesoft BASIC with a Uthernet card inside the Apple IIe, and it did everything in Applesoft. Everything was peaks and pokes and all that. It actually worked surprisingly well. It actually wrote the images that's displaying off the disk. So when you made a request, you'd hear the disk fire up and load it up and all that. And it worked well. The main issue was the memory copy. Memory copy was really slow. And so, if you put a routine in there in assembly language to actually do the memory copies, it's actually pretty nice. So, no demo this now. It's not really an exciting demo because especially it takes long for it to load and all that. But it's on YouTube if you're curious about that. Another thing I did, I was playing the game Kerbal Space Program, and so I thought it'd be interesting to try to port that to BASIC. These are just sort of joke ports and all that. But so I did, and actually, surprisingly, it runs fairly well as long as you're only doing things in 2D and don't care about the graphics that much. One thing that turned up was a bug in my BASIC tokenizer. I used arctangent for the first time, and it starts at AT, and so the token parser gets tripped up by like VLAN, whatever, whatever. And it's sort of interesting, so I was wondering, how's Applesoft handle this? And there's a clever way where you order the tokens right, and there's like a hack way where you put a special case for it, and it turns out Applesoft actually uses the hack way, and so I did mine too, where you actually special case arctangent. So it's one of those things, like I'm always finding bugs in the tokenizer because once I use something more obscure. Recently, turned out that for years my parser for tab was broken because the actual document you find in the first Google search is missing the parentheses on it, and I hadn't run a program that had tab in it forever, apparently. Another thing I did, this is the one I was most famous for, my 15 minutes of internet fame here, was play the game Portal. It's not the original Apple II game Portal, but the Valve one from later. And so I made that version of that in Applesoft, and it was like a slow news week, and so I actually had interviewed for magazines like The Register in England and a bunch of other stuff. And so yeah, you can play the game, run around. And the game physics you can do in Applesoft is actually not that bad. And a lot of the behavior you see in the game, and this naturally flows out of the game physics, is sort of interesting too. So you can download that and play that. And at the end, when you beat the original game, it plays the song still live, like a video. And so I of course, put that into the Apple version of it. And I just went peeks and pokes in BASIC, and it sounded horrible. And so I'm like, man, this would sound so much better if I had a Mockingboard card or something. And so that started a long tangent where I spent a lot of time learning all about the Mockingboard and AY3 card and all that. So I tried to get a Mockingboard. It'd take actually a year for me to eventually get one. And so one thing I did instead is took a Raspberry Pi and hooked it up to essentially a Mockingboard board chip I built myself. And so I built a chiptune player. And so it's hard to see this, but it's got all these LEDs too, because like LED displays. My office, I actually built an entire, it's not Apple II related, but Back to the Future time circuits in my desk of all the LED displays and stuff that I have there going there. So. But this too, so this is how I learned. People seem to think I sort of jumped straight into Mockingboard and figured it out. I spent a whole year messing around with the Raspberry Pi, driving more or less a Mockingboard, and developing all the tools before I started doing the other stuff. And so around this time, my life got a little bit stressful. My college professor, I was up for tenure and all that. And so I found 6502 assembly language coding to be very, very relaxing somehow. And so I started doing a bunch of other programming, when I should be doing other important things. So the one thing is this Chiptune Player that I mentioned. So let me close all the other windows. Yeah. Demo that real quick. So this is a Chiptune Player. So it plays Mockingboard music, and so unlike the stuff we saw the other day where people are going from the MIDI angle, converting it to Mockingboard, what I did is the demo scene and things like the Atari and the Spectrum people, they generated a file format called the YM5 format based on their chips. And they have a lot of out there. There's all this chiptune music that I always thought was pretty amazing. And it uses the same chip as the Mockingboard, so there's no reason the Mockingboard can't play songs like this. The problem is their format, it uses some weird compression, LHJ compression, and it's interleaved to compress better. So what it means is you really can't play you have 14 registers you have to write the Mockingboard, and they interleave them. And so to play them, you have to constantly jump that far into the file. And so in order to get playing the Apple II and fit in 48K on the fit 48K, it has to go and it compresses with LZ4 in chunks, and then while it's playing, it plays two of the chunks, then it decompresses the third one when it's running, it's interrupt driven. And so it's really complicated, but the end result is you can play on a 140K disc, you can fit about a half an hour of music here. And while it's doing it, it's got the little raster bars and the stuff and all that. And so it's got all these on here. So that was one project I was working on, and there's some other things with that. So eventually, I did finally get get it all working, and I finally got an actual Mockingboard in the mail, and I started running it, and it actually doesn't sound that great. And so I've wasted weeks of my life trying to track this down, and I still haven't figured out exactly what it is. So it sounds great on the emulator, but on the actual Mockingboard, there's very certain sequences of music you can send that glitches out the sound. And it doesn't happen with no regular songs. It only happens in these sort of extreme chiptune things. I've narrowed it down to a very certain set of data you send to it. It almost looks like what happens is the way it works when it's counting out the frequencies, it counts, and when it hits the the value, then it resets and generates the waveform again. It seems like it's missing that, and so it somehow goes past it, then waits the whole way till the counter overflows, a couple milliseconds later to do that. And so if there's any experts here on why this might be happening, it would be interesting to see. And people have said, well, maybe your code is doing it wrong and all that, and it could be true. It could be my code doing it wrong. The thing is, if my code is glitching in real hardware and not the emulator, well, that actually means that an emulator is not doing it right rather than real hardware. So it'd be interesting. This has been bothering me for months now, but I still haven't solved it. So the other thing I'm working on, that's the one that is mostly building up to here, is I've been working on a game, and it's called Talbot Fantasy 7, and it's sort of silly. It's like not really quite a Final Fantasy clone, but it's based on the Final Fantasy games. And it's actually based on a bunch of college and high school inside jokes when I was in college and high school. Final Fantasy 7 came out when I was in high school, and so my one friend who was playing, he was a psychology major. So unlike the rest of our roommates, we were engineers, we always had to work. He had time to be playing video games and all that. So he'd play them, and what he'd actually do, he'd grind through the game whenever plot would happen. He'd do a plot, we'd all run in to see the cutscenes and stuff. And we'd make up our own little things. So we made up some jokes about what the game would be like if, about us personally were in the game. And, it's been 20 years. And so at this point, I thought, well, I wonder how hard, just like my other, basic games, like how hard could it be to make this? And I thought, I can turn this out in a week or so. And it's been 1.5 years, and it's still not quite done here. And I was hoping to finish it for this. It's still not quite. But I have some demo here to do it. And I was going to show a little bit about, how I develop these things. So let me go back here. So I developed this under Linux, as you probably, not that window. I had to reboot my laptop and all my windows got messed up. Let's see how this works. So what I have is I develop it on C under Linux, and I wrote some routines that are basically a graphics emulator that emulate, the Apple II graphics by reading the memory map and do this. And that way I can develop under Linux, and then debugging is a lot easier. If you're trying to run things on the actual Apple II and something goes wrong, trying to debug it. And even debugging in Apple Win, while it's gotten better, it's still a bit tricky. But here, I can just stick printfs in my code, and I can get it mostly working in a very low level C, so like 6502. And then when I have to port it over, it's a lot easier, and I can make sure the algorithms go and all that. And it's actually, start out just as a low res emulator because my graphics here are mostly in low res, but it can do high res now, and you'll see later I actually did some weird vapor lock stuff, and it can sort of roughly do that too. So this game, Final Fantasy 7, that's supposed to be me, sort of. And a little symbol impulse sword was an LED. We're an electrical engineers, so the whole joke we had was all the swords would be different electrical components and all that. For this, it's only this, and so you can pick your player, you can put in your name. I'm going to skip that. And so this is the one thing that, a lot of the games, my favorite part of it is just flying around above the scenery and all that. And so I thought, hey, can we do this Apple II? I was going to fake it out at first, and then I realized and looked at the math, like, it might just barely be possible to do this. So this is going a lot faster than it would in real hardware, but it is possible. I'll show the Mode7 demo later. It actually has it. But so it is possible to do this, like Mode7 type graphics. It takes a tile background, squishes it down using a bunch of math, and then putting the sprite over it. And the trick to this is having a fast multiply. So you need to do, it's a fixed point 8.8 multiply, so 16 by 16 and 32 multiply, which is really slow in the 6502. Like, I think the best you can get is maybe like 700 to 1,000 cycles. But it turns out if you do some clever math, you can get this down to about 200 cycles. And the way you do this, it's sort of not complicated, but people figured out a long time ago. But if you do the quadratic formula and stuff, you can change the two multiplies into a lookup table in a table of squares, and change it to a lookup and some subtractions. And you have to waste 2 kilobytes of RAM for a lookup table, but then you can get the multiplies down to 200 cycles or so. And so 7 multiplies for each pixel, you can get the screen. And so by doing this, you can get, I cheated a bit, calculate up here and stuff, but you can get about 10 frames a second or something, which is actually pretty nice. So, and so yes, I'll talk a little bit later, but then, you can land your ship and you get out and walk around and all that. And I think that effect should be possible. I haven't implemented that yet, but using the same code. And then, you're fighting and, you can attack and, let's see here. I should have sped this up for the demo so I actually get to do some attacks. And you can do summons and stuff. And some of these are sort of joke summons like Metrocat. There was a, where's my keyboard working here? Oh, it's not going to work, is it? Vortex cannon. So some of these things, like we built this thing like a little vortex cannon, which is a box, serial box you hit, and it shoots, air at people like that. We had one of those in our dorm, and we thought it was funny. The other thing Metro Cat there was he was a cat that appeared on the cover of the Washington Post Metro section. We thought he was cool looking and hung him up, and then we eventually ran him for SJ president of the college and all that twice. He never won, but the second time they actually banned writing candidates because we were causing trouble and all that. So, and another random encounter here. There's only in my room. There's only like 10 different enemies. I want this to run in 48 kilobytes. So let's see the Metro Cat here. Yeah, the cat comes and gets me and all that. So fitting it's hard. Actually, the hard part is going to be the dialogue. Getting text in the Apple II is a bit hard. Let me get over here to the. So here, when you go to these places, this is sort of based on the University of Maryland, and it's called Talbot Fantasy. We live in Talbot Hall, which is like this. And you can go here, and we can talk to the people and all that, and and a lot of these are silly inside jokes. They're playing the Super Nintendo there. You probably can't tell. Some of these people are famous people. This guy right here, these days, he's an Ivy League college math professor, and this guy here is actually a higher-up guy at Firaxis, the civilization programming people, and this guy here, he's a high-end lawyer now, so it's sort of funny how these things all work out. And you can go to some of these places, and I was having fun with I have to sneak through here. And I can skip that currently because it's debugged. I was having fun with some of the scenery and making pretty scenery and all that in low res. So I just draw these all with regular paint program and bring them in and all that. So showing this, just showing off what this is. And so the plan is to eventually, the plan is eventually to get this going on the Apple II. I was hoping to have it done by here, but it isn't. If you go play it now, the disk image is there. You can do the flying part, you can walk around the scenery part, but that's about it. But I've got all the art done finally, and I've got all the logic done, which is the hard part. And so the next part, the rest is trying to get it in 6.5/2 assembly and all that. And I also have some Mockingboard music I want to play at various times. And actually from the Final Fantasy VII, I found the sheet music, and it actually sounds surprisingly good on the Mockingboard. But again, trying to fit this all in 48K, especially, it's probably going to be big enough I'm going to have to load from disk, so I can't overwrite DOS. And so that'll be a challenge, but I think it should be, possible. So, and the other thing, the credits. The credits are the interesting part, and this is the thing I got done, actually did get done before coming here, and I was going to show it off here. So, at the end, in a lot of the games, you're, they show you riding off into the sunset, often riding in the game, in a chocobo or something, which is a giant bird creature and all that. And I thought I should do this, and but it'd be cool, low res isn't that great, so why can't we do it with this? So this is split screen, this is text at the top, high res in the middle, low res here. It's doing the vapor lock, refines where it is, the cycle counting to get here, flips it off screen, and it's playing some, you can hear that, but it's playing some Mockingboard music too, so. But yeah, it's some of the most challenging programming I've done. I was going to take that back. It's the most challenging program I've done that worked pretty easily the first time. I've been trying to do some ARM assembly language, setting up the caches on the Raspberry Pi. It's about 10,000 times worse. But so anyway, yeah, and just repeats here. But so I like doing this because I imagine if I went back in time into the 80s and showed my young self this, I would be like, that's not possible or whatever. So it's I'll repeat here forever though. But so yeah, that'll play over the end credits when you beat the game. So a few other things. So the Mode7 demo, I'll show that in a minute. I'll show it last because AppleWin, the sound on the current version of AppleWin, if you put PC speaker, not PC, the speaker and Mockingboard at the same time, it glitches out for some reason. So I'll have to play a different way. So that one though, that was when I originally made the flying part. It was so cool. I'm like, this would make a good demo, like demo scene demo. And I didn't really know much about the demo scene, except I'd seen the future reality demo and some other things. So I hacked together something. If it could be a demo scene demo, I had to have raster bars and the star field and greets and all that. So I did that. I also wrote it up. So the most recent of the journal, it's full screen again. The proof of concept or GTFO journal you may have heard of, a hacker journal. So the most recent one, actually an article on my Mode7 Demo, and you can go read it. And you can read on my website. I have a slightly more elaborate version of that paper that they kept it a little small for the journal, so some extra stuff on things. So I'll run that at the end. As I said, I can run a different emulator. The other thing is messing around with, and I had some help from some people who are here because this is the Entropy Demo. You may see me running it earlier. And so this is from the Beagle Brothers 2-line BASIC demo from years ago. And so I guess I can actually run it and show it. So it's a cool little demo that someone had submitted, and I was like, wouldn't it be great to convert that to, since I'm in a demo scene mode, convert it to assembly language, see how small we can get it. Lots of things like DOS, they have all kinds of demos where people do crazy stuff, like write entire paint programs in like 8 bytes or something. And I'm like, how small can we get this? So it got down to 128 bytes. And all this is doing is it's drawing, originally in BASIC, this box. It sets it up a shape table, X draws it, and X draws it across, and then randomly it makes it bigger, and that's when you get these weird shapes. And then it overwrites it again, and when you overwrite it again, you get the double box, and it goes back and forth, and now we just thought it was a cool little demo. And so we got it down, I forget how small we got it to, not much bigger than 100 bytes or so. So it's sort of a fun little demo. So I got on the demo scene thing, a little old for this, but it's starting in the demo scene type stuff. So just a cool little demo on the side there. And yeah, I'll get back to questions. Like, let me run the Mode7 demo now. So I'm going to run that in MAME because the sound, I guess, might matter in this case. The sound is sort of going. So so demo. So it's loading. I actually loaded the high-res memory so you can see it loading. And if you look carefully, you can see my little logo up there. So the code actually has that pattern in it. To have my logo, so I did spread it across the high-res pages, and has a scrolling text there, and just like a lot of demos do. It fades out. That was a lookup table to do that, and then has a little bouncing geometric shape because I do it in demos. But then it starts rotating with the. So the Mode7 code, you can actually do any background you want. Tile map, here it's doing a checkerboard, but you can do yourself a map. And it's playing Mockingboard music in the background. So all this fits in 8K, including all the music. So it's compressed. It's all in 8 kilobytes. And it's flying across the scenery here, just like you saw before. So this is the frame rate you can get on this in the game if you're actually playing the game. You didn't get as good as it looked before. And then you also need a star field because it's a demo, so you're flying through the star field. Flags off, and then of course you have to have some raster bars and thank all your contributors and stuff. And then I tried this isn't splitting here, I just used inverse text to make it look like it's on the graphics mode there. And so it plays this is a random assortment. I know when you see people being thanked in demos, it's always you wonder who these people are. And so this is some random people I knew in high school and various things I did, like various VBSs I ran and things like that. So, and the music, I didn't write this music. If anyone out there is a good Mockingboard music player, it'd be great to have help. I found this one online, some Russian guy, and he could never contact and ask for permission. So hopefully I don't get the Russian mob after me at some point for stealing YM5 music at some point. And the reason I don't use MAME for this more often, I always have trouble closing this. So, yeah, I've actually finished a little earlier than I meant. So, any questions on any of that stuff? I can go back and if there's a little bit of time, I can show some of the basic programs. I wasn't sure I was going to have time for them. So, any questions on anything?
For the table of squares, did you pre-calculate that, or did you have that done on two-side?
It's generated on the fly. It doesn't. I'm pretty sure it's generating on the fly. It doesn't take that long. I had to double check, but I'm pretty sure it's generating on the fly. It uses a lot of self-modifying code too, so and because of the way the Mode7 equations work, you don't need all the high bits. So it also, I spent a lot of time optimizing it. So it throws away a lot of the results and all that, and that's part of how you get down to 200 cycles or so. Yes.
For anyone anyone who might not know Super Nintendo, can you explain what Mode 7 actually is?
Oh, yes. So, yeah, Mode 7. It's called Mode 7 because that's what they call it, the Super Nintendo. I've actually done some minor Super Nintendo developing at various points. So what it is the, I should have made some actual slides for the Mode 7. So you have a tile map, so, grid of the tiles with the data on it. And it transforms it, so it can transform it, it's sort of, the actual Super Nintendo hardware does this in hardware, and it can do some pretty elaborate, like rotates and shifting to make it look like 3D by taking it and sort of shifting it back and squishing it in a bit. And so what this does, the code does, is it actually goes and it walks across the screen, and it finds each pixel on the screen, where would this be in the tile map if I rotated and squished it, it looks sort of 3D-ish. And so what it does for each of those things, at first it calculates, where in the tile it is and looks up the lookup table. And for more advanced things, the tiles can have, really complicated graphics and look really nice. Here, I'm just using like a 64 by 64 tile map. Each one's a solid color, so you probably notice like the checkerboard one, that's the size of it. And I also made, someone's like, oh, you should make it go into double high res. And so I'm like, oh, that wouldn't be too bad because when you're calculating, so I threw it together in a day, and then they're like shocked. Like, I can spend my whole life trying to make double the res working, and how'd you do it in one day? The thing is, the way you're drawing it, to go from single to double, I just had to shift over by 1 pixel and then write it to the aux page, and it actually wasn't that much trouble. The way is the graphics are sort of grainy as they are, so they look mildly better, at least what I was using in double low res, but they're not, not great, and your frame rate goes in half, so it's not really worthwhile to do the double low res for that. Other questions? Yeah.
Vince, could you just drop it out of full screen?
Oh, yes.
Kind of cutting it off.
Oh, sorry. Oh, yeah, so my code, it's all there. I have my increasingly inaccurately named DOS33 FS programs GitHub tree that I actually put everything in. It actually annoys people sometimes. They just want to get games and stuff, and they have to download the whole thing. But that's my website there, off there. So the code for everything I showed, it's I open source everything. The code's all there, so if you want to look at it, it's all there, free for download and all that. In general, sometimes it's hard to build things not in Linux just because it's where I build it. And you have to have the CA65 assembler installed usually to build things. But I also have disk images there too if you don't want to build things yourself. So, other questions? I think I have a little bit of time here. I can show off real quick.
Portal 2.
What do you want to see? Request?
Portal 2 on the Apple II.
Model 2?
Portal.
Oh, Portal 2. Oh, Portal. Yeah. Let me show you Portal. I called it GladoS 3.3. It's a DOS 3.3 behind, and no one actually picked up on it really about it, but it's what it's called. So yeah, Portal. Yeah, you guys do. So it isn't basic, so it takes a little bit to reload, but he's got here. I always put a cracked screen on it because, growing up, I actually never played many games that I should admit this didn't have cracked screens on them, so I just figured that's what games had on them when you started playing the game. So yeah, so there you are, your shell there, and let me see around the keys. So yeah, and it's actually a really painful interface shooting the portals. You have to go over with the IJK keys to what you want to do. So it's talking there, and you can see the weighted companion cube up there, and trying to remember how do I shoot. Okay, there's one. And let's come down here and let's shoot the other and see if bad things happen. Yep, so it shoots through the portal and it kills me. It's like you died, try again. And let's see if we can do something useful with the portal here. So let's see if we can get it across the lake here. So yeah, this is actually isn't actually very much Applesoft code. It's actually, let's see if we can make this jump here. Yeah, I've got through. So, the physics isn't much. It's just some gravity, and I have some special cases for the lasers and stuff. And it skips, I always joke, like half an hour later in the video, but I only have the 2 levels here, and then you're at the final battle here and all that. And I'll sit here and play through the whole thing here, but so people said, can you add mouse support, joystick support? You could. It sort of makes everything a lot more complicated. And then people are saying, why don't you do this in assembly language? And at the time, it was like, didn't seem like worth the trouble, but I have another demo I didn't show. Some people might have seen it playing upstairs last night, where I made it's still live at the end. I did finally eventually, missed. I did finally get that going on the Mockingboard with the Mockingboard sound. And to do that, in order to make a nice 16K demo, I actually re-implemented this very scene right here. Oh, sorry, I'm putting it the wrong place. I re-implemented this scene in assembly language. And so it's not too bad. Part of the problem was, it's just using xdraw. That's actually an interesting thing with this right here, is I'm xdrawing the shapes, even her. And so in order for that to work, she can only go in even things, and the background has to be the right color of black, so she's orange and blue. If she accidentally gets off by things, suddenly she'll be green and purple. And so it's sort of, sort of annoying. So, any other questions? I have a few more minutes here if anything else you want to see. This is the, it's not that exciting to hear watch me playing Portal and anything else. I could probably show Kerbal Space Program really quickly if anyone wants to see that one. Yeah, it's set to loaded high because this one got too big. And if you ever played the original Kerbal before it originally got taken over by bigger companies, the loading screen looked like. And it's actually not doing anything here. It's just making a long loading screen just because that's what the original game did. And it's got the graphics to be squint a bit. And it's little humorous things as the actual game does. And this is actually also sort of why I got interested in Mockingboard sound too, because it plays the theme here, but just to paint some hopes. And there's a Mockingboard version of this I posted too that you can go see. And in an assembly building, and you can build things. In the game you build this graphically, but here you just say parts, and it it's really simplified. It's a very lousy rocket. It's going to explode. How many parachutes, how many struts. The game, if you play the game, the joke is you build a lot of struts to hold things together. So, and you can pick what your pilot is, and so we can pick Jebediah, and it says my thrust to rate ratio is like 0.3 here, which means it's not going to take off, but we can pretend. And in the game, you can see a little window here on your pilot, and he smiles or frowns based on what's going on. I can launch it here, and it's going to crash right away probably because, explodes, and he's looking sad because his rocket's exploded. So anyway, that's that. This again, it's all in BASIC, lots and lots of BASIC. So, any last questions? Thank you.